Hi, good afternoon, everyone. My name is Simi Oduwole, and I'm joined by my colleagues Paolo Louzado-Feliciano and Alexandria Cruz, and we'll be presenting on per and polyfluoroalkyl substances, also known as PFAS.
Simi, if we could just wait just a minute or two as attendees are rolling in, and I'll go ahead and introduce the team. Thank you so much.
Okay.
But just so for those of you that are just joining us, we're getting ready to start our PFAS and Florida Firefighters. So just wait a couple of minutes and we'll make sure everyone has a moment to join in. Okay, so it is 12:05 here in Miami, Florida, and good afternoon. Welcome to the Firefighter Cancer Initiative's monthly cancer seminar. This is our last seminar for the 2021 series, and we're closing out with a topic that's important to our Florida firefighters on PFAS. Today, we actually are presenting TAPA's array of projects that are on the topic of PFAS offered by our Firefighter Cancer Initiative. So we'll have three unique presenters that will be talking to you about this topic. So today we're joined by three research associates to the Firefighter Cancer Initiative, Ms. Paolo Louzado-Feliciano, who will be presenting shortly on the Florida Firefighter PFAS survey, Simi Oduwole, who will be introducing the topic for us on PFAS, and then Ms. Alexandra Cruz, who will talk to us about the PFAS registry. So there are two opportunities to ask questions to our presenters today. On the bottom of your screen, there's a chat button. So if you want to, or the Q&A button, if you want to enter your question there. At the tail end of the presentations, we'll be entertaining questions from our presenters. And also at the end, we'll allow an opportunity for vocalization of and raising any questions at the same time. So without further ado, please join me in welcoming our presenters, and I'll turn it over to Ms. Simi Oduwole, who will introduce the topic of PFAS. Simi, take it away.
Hi, good morning, everyone. Again, my name is Simi Oduwole, and I'm joined with my colleagues Paolo Louzado-Feliciano and Alexandria Cruz, and we will be presenting on PFAS. So to give you a little bit of background on what we'll be presenting on today, we'll be presenting on PFAS and Florida firefighters. I'll be starting by giving an introduction on what PFAS is, followed by Paola, who'll be giving a brief synopsis of the Florida PFAS pilot study, and Alex will be completing the National PFAS Registry. Per and polyfluoroalkyl substances are a large family of synthetic compounds that are widely used throughout society. PFAS is known to persist in the environment longer than any other man-made substance. As you can see to your right, there's the photo of PFOA, which is a type of PFAS. PFAS are a large group of synthetic chemicals that are used in a variety of everyday materials, including nonstick cookware, carpet, textiles, high-performance outdoor gear, coated paper and cardboard products, some firefighting foams, and a variety of cleaning products, paints, varnishes, and sealants. These compounds repel oil, water, grease, and stains, and also resist high temperatures, as well as reducing friction. PFAS has been used since the 1940s. Their persistence in the environment has earned them the distinction of being the forever chemicals, which you will hear us say pretty often today. This is because they don't naturally degrade in soil or water. This is due to their persistence in the environment and widespread use. Most people in the United States have been exposed to PFAS at some point. As I mentioned earlier, they're called forever chemicals because they take up to 1,000 years to break down in nature. As you can see in the pinwheel to your right, there's a few pictures of some of the everyday sources that we see PFAS in. So how does PFAS get into our bodies? We can find PFAS in our bodies by cooking with nonstick pans, products that contain PFAS, such as yoga mats, water repellent jackets, and Tupperware. PFAS can also be contaminated in our food and water, as well as air and dust. PFAS is also known as the forever chemical because of their long biological half-lives. As you can see on the left, there are 5 examples of PFAS chemicals. The elimination of PFOA has a half-life of 3.5 years. The elimination of PFOS has a half-life of 4.8 years. The elimination of PFHXS has a half-life of 8.5 years. And given the long half-lives and world dispersion, exposure to legacy compounds will persist for time. As you can see on the graphs to your left, the production of PFOS and PFOA has declined, in addition to the PFAS serum levels declining as well. From 1999 to 2014, the blood PFOS levels have declined by more than 80%, and the blood PFOA levels have declined by more than 60%. The PFOS and PFOA have been phased out and replaced. However, individuals may still be exposed to other forms of PFAS. I will now hand it off to Paola, my colleague, who will be presenting on the Florida PFAS pilot study.
Okay, good afternoon, everyone. Thank you for joining us in seminar today. And thank you, Simi, for that great introduction. So as she mentioned, I'm going to be going over the Florida PFAS pilot study. So you might be wondering, why are we interested in studying PFAS concentrations in firefighters? Well, some of the reasons being that these chemicals can be found in firefighter turnout gear, and they can also be released during fires, which firefighters might be exposed in during fire suppression activities. PFAS are also a component of aqueous film-forming foams, which are some products that are used by firefighters, as you can see in this picture, during fire suppression activity. So in order for us to achieve our study goal of characterizing PFAS exposures, we decided to do it across two aims. Our first aim was to administer a one-time survey on PFAS and AFFF use, and their second aim was to assess exposures of PFAS through biological sampling. So our study design was a cross-sectional study, which this essentially means that we were going to collect data on one point in time. Our inclusion criteria for this project was pretty open. Firefighters needed to be at least 18 years of age. They needed to fluently speak and write in English. And then we decided to include either incumbent or retired firefighters, as long as they had a 6-month of firefighter experience. Some of the study activities involved were pretty straightforward. We needed to obtain study consent, which is form firefighters fill out before engaging in any study activity. Then they were asked to complete a one-time online survey and donate a blood sample. We collected data from 2 fire departments from June to October 2021 of this year. Up in the screen, you can see our recruitment flyer. This flyer was shared with our fire department liaison, and the liaison just distributed it forward to firefighters from the department we were working with. And during that time, we received questions, and we came prepared to answer any questions that might arise from participants that decided they wanted to join the project. So I'll look into what our field operations look like on data recruitment or data collection day. Our team was established at a fire station or a fire station headquarters. And essentially the fire crews were, rolling into the station or the headquarters. We would give them a spiel about the project. We would go over the consent form, and we would answer any type of questions that might arise during this time. After they were 100% sure they wanted to participate in our project, then they would complete a survey, which was given to them in a tablet. They would press submit, and then they would just donate a blood sample. We processed these blood samples at the headquarters, and they were sent to the lab same day for them being further analyzed. In terms of data analysis, the data we collected from the surveys were analyzed using SPSS, and the blood serum analyzed by the NMS lab was the 7 PFAS chemicals that you see here on the bottom of the slide. So for Fire Department 1, we recruited a total of 108 firefighters. 94% were male, 77% were Caucasian, and 22% were Latino. Our group's mean age was 40.3 years. Almost 20% were college graduates, as well as reported having a second job. And most of our participants have worked an average of 14.2 years, so they were pretty seasoned in the fire service world. So here you can see the data we received back from the lab. So in the x-axis, you're gonna note 3 different groups. The one in red represents our firefighters. So these are the participants that we collected data from. The group in orange is the NMS sample. So the lab had a sample of individuals they have tested for, and they have this data, and they were so kind to let us compare what we got from firefighters to that sample. And then in green, you can see N. Haynes. So this sample represents the US population. And then on my y-axis, you can see the serum concentration level in nanograms per milliliters. So I think it's important to point out that when we look at these serum concentrations, we can see that the results reported for firefighters are actually lower when we compare it to the lab sample or the rest of the US population. And then I just wanted to point out that from the 7 chemicals tested, PFAS was the one that had the highest concentration among this group of participants. And then we were also curious to see what these serums concentrations look like for different subgroups of firefighters that we recruited. So in the x-axis, you're going to see 5 different subgroups. We had airport firefighter, fire investigators, incumbents, probation firefighters that had at least 6 months of experience, and then retired firefighters. And again, in the y-axis, you can see the serum concentrations. So I think it's important to note here, if you look at PFAS, that for fire investigators, the group in orange, we saw kind of like a higher concentration compared to our other groups, which can mean that they are just more exposed to that PFAS chemical. For our second fire department, we recruited a total of 100 participants. The majority were male, Caucasian, and only 9% was Latino or identified as Latino. Our group mean age was 39.7 years, so slightly younger than our first fire department. 25% were college graduates, and approximately 22% reported having a second job. And then most of our participants have worked an average of 15.3 years, so slightly higher than our first fire department. So in terms of the serum concentrations that we got back reported on, we can see on the x-axis the 3 same groups, except that now in blue, you're going to see the firefighter sample group. In orange, you see the lab sample, and in gray, you're going to see the general US population. So we were sort of impressed that, again, the concentrations we got reported back for firefighters were lower compared to the other 2 groups we are displaying here. So for NMS sample compared to Haynes, firefighters are still showing lower serum concentrations for the PFAS chemicals that we tested for. And then among all the chemicals, again, for PFAS, they had a slightly higher concentration when we compare it to the other PFAS chemicals. So here you can see in the x-axis, we have, instead of the 5 groups you were shown in the previous slide, we have 9 groups. So in difference from this department, we had firefighters that identified as being part of the hazmat team, and also fire instructors. So in terms of serum concentrations for PFAS, again, this was kind of like the one that had the highest concentrations. And then for the firefighters that identified being part of the hazmat group, their concentration was higher. So some big takeaways from the data we've gathered is that even though we can see that for firefighters, these serum concentrations are lower, PFAS is still a man-made chemical, and it should not be in our system. It's also important to know that of the chemicals we analyzed, 5 out of the 7 chemicals were present in all of the serum concentrations we got back from the lab. And then it was also interesting to see that from retired firefighters, they still had PFAS in their system, which that half-life kind of like, it is true, like even though they might not have been, in participating from prior suppression activities involved with the AFFF foam, it was still, in their system even after retirement. And then I guess, this as part of a team, we think that there needs to be more research done on this topic, and especially in the fire investigator subgroup, because we saw that higher concentration for PFAS compared to other subgroups. And it would be really interesting and, just to add to the scientific literature more about why that concentration was higher compared to other subgroups of the fire service. So now I'm going to leave you with Alex Cruz, and she's going to give you an update on the National PFAS Registry.
Hi, I'm Alex with the Firefighter Cancer Initiative, and we'll be sharing with you this afternoon an update on our progress with the design of a dedicated firefighter PFAS registry. So in 2018, Florida firefighters raised concerns to our research team about their individual PFAS exposures from their work environment. And we wanted to learn more and quantify the concern about Florida fire departments. In 2018, we used a cross-sectional design study to collect survey information from 131 Florida fire chiefs and other fire department leaders. Over 80% of survey respondents indicated their fire departments used aqueous film-forming foams or AFFF as part of their fire suppression activities. As you can see from the figure on the left, 24.5% of firefighters knew the brand or manufacturer of the AFFF, 17.6% were aware of the original or newest formulation, and 4.6% were aware that the AFFF brand had PFOA or PFOS as a main component. Through various discussions with Florida Fire Department leaders, we decided to design a dedicated firefighter PFAS registry that would support the needs of firefighters in tracking and archiving PFAS exposures and serum PFAS results. To start this process, we are interviewing various stakeholders and subject matter experts on what the PFAS registry should look like, what information it should collect, and how it would support understanding PFAS exposure and intervention effectiveness. So the overall goal of this qualitative study is to understand the different perspectives of a PFAS registry and its components to provide firefighters with a way to track their PFAS levels and reduce their exposures to decrease adverse health effects. And we will achieve our study goal through the completion of the following aims. So the first aim would be to administer a one-time survey via REDCap on basic social demographic information. And our second aim is to assess different perspectives of a PFAS registry through individual interviews with PFAS stakeholders. So we adopted a qualitative study design, and the inclusion criteria just includes stakeholders who are 18 years of age and older, and any person who's willing to complete the study survey and interview. Study activities include obtaining verbal consent and participants completing the survey and interview, and data collection started this year on November 12th. So here I will be presenting the demographic data of stakeholders we have interviewed so far, which are 5. 60% of participants were male, all were Caucasian. The participant group mean age is 56.2 years. 80% of participants were college graduates. 60% of all participants reported a job in government, 20% reported a job in academia, and the other 20% categorized as other. Most of our participants had worked an average of 6.2 years. So 7 themes corresponding to 4 broad categories were derived from the data so far. Regarding health registries in fire departments, stakeholders described a PFAS registry as a dedicated place for PFAS data and a place where firefighters can put information about their serum and PFAS levels. In terms of PFAS, stakeholders emphasize the importance of tracking exposures to better understand PFAS in firefighters. When looking at challenges and outlooks, stakeholders express that firefighters may be hesitant to share personal information and that firefighters may not be knowledgeable about the purpose of a registry. And finally, regarding the PFAS registry itself, stakeholders described project success as being measured by addressing concerns of the fire service, and using social media and attending conferences for participant engagement also emerged as a theme. Again, these are preliminary findings from a limited set of interviews with various stakeholders, including firefighters and subject matter experts with the different lenses of the problem. Once we complete all of the interviews, which we will know once we reach saturation in our themes, our team will shift gears to work with information technology to design and build a digital firefighter PFAS registry. It is our hope that this registry will support for routine monitoring for PFAS exposures and trends in firefighter serum PFAS levels. In the long term, the registry can inform firefighter health and safety practice and the science on PFAS, as well as evaluate impact of interventions to reduce PFAS exposures. I will now invite my colleagues, Paola and Simi, back to address any questions that you may have. Thank you.
Okay, so at this time, we'd go ahead and like to invite questions from our audience members or from our firefighters or scientists that are on the line. We have some here in the Q&A that I'll start tossing out. So Paola, one of the questions from our audience is, NMS is analyzing the Department of Defense firefighter serum for PFAS. Do you know if that comparison data is included in that? Does their comparison data include in the firefighter group? So the slides you presented earlier comparing serum PFAS levels between the three groups?
For NMS, no. So I think like NMS just provides like whoever they've tested these PFAS chemicals for, like their lab sample is the same chemicals compared to like what they reported back to us. And then they also provided like the average for that serum concentration for the NHANES sample.
And so I think the answer is yes to your question,
Yes.
indicating that the values of the NMS in those slides correspond to DoD military firefighters. And so the comparison group in your slides were these civilian firefighters from the two fire departments you tested, and then the bar that represents the NMS lab DoD firefighters, and then the American population represented through the NHANES data.
Yes.
Okay, great. So there's a question here on hypothesis testing. Does the group have any sort of indication as to why you're observing PFAS levels generally lower in the firefighters that you tested compared to the US population?
Yeah, so I think like one of our hypotheses is that it might be due to good decontamination control practices after fire suppression, good handling of like AF foam. So kind of like these routes of exposures like being diminished, and then their concentrations for these, chemicals are lower because they kind of like stop exposure. So
And I would add to that, I think part of this, as Paola is alluding to, is that these are two relatively small samples, two distinct fire departments with relatively small samples who generally have better decontamination control practices, which could be trickling on to how they handle and use the AFFF foams or other points of exposure for PFAS. But again, this is not external generalizable to the full fire workforce or the Florida firefighter workforce. It's sort of a first step in understanding how serum PFAS levels compare and contrast to other populations.
Yes. Other questions?
So we have another question here asking if it's possible to describe the published literature regarding defined health effects from serum PFAS levels that we've described. So I'll jump in before I turn it over to Simi, but basically the goal for these three studies has not necessarily been to describe health effects or its relationship to the serum PFAS levels at this time. It was more to feasibility of collecting the blood samples and characterizing the PFAS levels within the first responders. However, in the broader literature, understanding PFAS, I think Simi mentioned some of the health effects that are related. And so Simi, if you'd like to jump in and describe those.
Yeah, so some of the health effects that I described earlier in the presentation was preeclampsia in pregnant women, kidney and I believe liver disease, and some other health effects. Like Dr. Caban mentioned, they're still preliminary, and one of the causing factors, obviously not 100%, but one of the causing factors of those health diseases.
Okay, thank you very much. So there's another question here. I guess this one's back for Paola. So when you presented data on the fire department number 1, it looks like fire investigators were included in that sample. Could you comment on why they may have higher values of serum PFAS levels?
So, I mean, I kind of have an idea, but it's my idea. I think that when fire investigators, they go to investigate a scene, they kind of like get really into investigating the scene. And it depends on like the type of protective equipment that they're wearing while they're investigating. If they're, not like fully suited, wearing a, something that would protect them from inhaling exposures from that scene, it might be, causing them to have more exposures to like chemicals being released from that fire investigation scene. So that's one of my ideas as to why their concentrations might have been higher. But as we mentioned, this is all preliminary results. It might also be, the water where they live, like the water source, like there's all these factors that might be also alluding to that.
Okay, thank you. We have a live question from John Wagner. If you'd like to unmute and ask the presenters. John, you're welcome to jump in and ask your question. Okay, we'll jump on another one in case we're having audio connection. Oh, there's John. Go for it.
Hello. Yes, my question was, I have not been able to listen to either one of the seminars that I've been on totally so far. Are they available on YouTube or any other website?
Dr. Sali?
Yes, I'll put the link in the chat to everyone, so you can see on our website, we have all of the seminars from every month. And so this one will be loaded in the next week or so, but all the previous ones are there. I'll put it in the chat now.
Okay, and what site are they on?
It's on our Sylvester website that's specific to the firefighters. So I will put it here for you, for everyone. And on that website actually takes you to our FCI page that you are able to see all of our active projects, information about our symposium that is happening in February that you're able to register for, that is happening both in person and virtually. And then the resources page that I just put in the chat that has all of the previous seminars, both recordings and the slides.
Great, thank you very much.
No problem.
And John, in addition to that, our team will be sending out an email to all of you, to all of those of you that registered today for the seminar, to access as well. So you can grab it from the chat where it's posted, or it'll be emailed out to everyone.
Thank you.
Our privilege. All right, Kelly, you're up with the next question. So Kelly East, if you're there, you're welcome to ask your question.
Hear me?
Yes, you come in.
Oh, okay. My question was just if there was any way to find out if there's current studies in our area that we can get involved in. And I'm calling from California, Berkeley, California.
Yes, so there's actually some academic centers in that area that are doing some wonderful studies. I'm going to connect you with a colleague, Matthew Alba. He'll be able to share with you in that local context. So we'll send you some partners in the research area that are working in that space there geographically.
Wonderful. Thank you very much.
Our privilege. Okay, our next question comes to us from Brian Gordon. I wonder if that's our firefighter, Brian Gordon. Brian, the floor is yours if you can hear us. Okay, it sounds like we're having some audio connection issues there. Just going through any additional questions here. Okay, I think we've answered all the questions for today. So I'll ask our team to go to the last and final slide there in your slide deck. Thank you all again for joining us for the last installment of our Firefighter Cancer Initiative seminar series. It's been a very long and interesting year, and we're thankful to be able to partner with all of you to share the information that we're learning. And in that same spirit, we want to share with you an important event, the annual National Firefighter Cancer Symposium that will be held here in Miami, February 24th and 26th. So if you're from out of the state of Florida and need a warm change of weather temporarily, we welcome you to join us at the symposium, which will take place Wednesday, Thursday, and Friday. Wednesday, there will be an open session for members that are interested in learning more about the firefighter cancer cohort study. The 24th will be a series of workshops for first responders to learn about mental health and cancer, decontamination procedures, how to write grants to FEMA, and other workshops. As well as on Friday, the 25th, we will have a jam-packed session with State of the Science Cancer. And then on the 26th Saturday, we hope you will join us to do our run, walk, or bike with our Miami Dolphins football team through the Dolphins Cancer Challenge. So the link is here on the website if you want to copy that link and learn more a little bit about what's on the agenda and the dates and times. We thank you very much for everything you do to protect our communities, to our firefighters, and we wish everyone a safe holiday and a very happy new year. Thank you to our presenters. and have a great week. Bye, everyone.
Bye,
Bye,
thank you,
bye,
everyone.
you.